Now, mechanics of machines. Now, this part here we will be doing, or we will be looking at clutches, friction clutch. Okay. So now, there are three different types of friction clutch that we will be looking at. The first is the disc clutch. It's single, either it is single or is a multiple disc clutch. The second type is the centrifugal clutch, and the third one is the cone clutch. So this is a diagram of a clutch with its pressure plate on top. This is the pressure plate, and the bottom here, this is the flywheel. Then this is also another diagram showing you, okay, the different parts of the clutches. This is the pressure plate, this is the disc clutch or the clutch plate, and this can be considered as the bearings. So friction clutches. Now a friction clutch has its principal application in the transmission of power of shaft. So it is used in power transmission and machines which must be started and stopped frequently. Just like, for example, a car in front of a traffic light. So when the light turns red, we have to stop the car. So during that time we won't be able to, or let's say we won't be able to switch it off. We won't switch off the engine, of course. So what we do is we need to disengage the clutch so that to cut off the power transmission temporarily. Okay, so and then after that, when it turns green, we need to start the car again. So therefore, if we are not using a clutch, then we have to switch on the engine again. But then if with the clutch, when the clutch engage, the power is being transmitted again. Okay, so that is a function, the main principal application of a clutch. So its application is also found in cases in which power is to be delivered to the machines partially or fully loaded. Now the force of friction is applied here for the clutch and is used to start the driven shaft from rest and gradually brings it up to the proper speed without excessive slipping of the friction surfaces. Then the contact surfaces should develop a frictional force that may pick up and hold the load with reasonably low pressure between contact surfaces. Okay, those are the main applications of clutch. So now we'll be looking at single disc clutch assembly. Now this is the assembly of a single disc clutch. Okay, here you have the clutch plate with both sides effective. Both sides here effective. Okay, so it is in contact with the flywheel and as well as the pressure plate. So a single disc or plate clutch, as shown, consists of a clutch plate. This is the clutch plate, okay, whose both sides are faced with frictional material. Both sides, that means one side here and the other side is here. Okay, so both sides being effective. Now it is mounted on the hub. This is the hub. The plate clutch is mounted on the hub, which is free to move in the axial direction along the splines. These are the splines of the driven shaft. So this part is actually the driven shaft. Here, this part here is the driving shaft. So the pressure plate is mounted inside. The pressure plate is mounted inside the body of the clutch, okay, which is bolted to the flywheel. Now both the pressure plate and flywheel, both the pressure plate and the flywheel rotate with the engine crankshaft or the driving shaft. Now the pressure plate pushes, okay, pushes the clutch plate towards the flywheel. So it pushes the pressure plate here forward so that it comes into contact with the flywheel here, the flywheel, okay, by a set of strong springs. So the springs here actually exert a pressure onto the pressure plate, okay, so that it can cause the pressure plate to move forward, okay, the spring. So when the spring is being compressed, what happens is the clutch will disengage. So when the pedal is released, the spring, which is an elastic material, which tends to restore back to its original length, pushes the pressure plate forward again comes into contact with the flywheel. That is the purpose of the spring with the pressure plate. Now, the three lever, also known as the release levers or fingers, are carried on pivots, okay, suspended from the case of the body. These are arranged in such a manner so that the pressure plate can move away from the flywheel by the inward movement of the thrust bearing. So when the pressure plate moves away, the clutch will disengage. Okay, so that is the single disc clutch assembly in general. So the bearing is mounted upon a forked shaft and moves forward when the clutch pedal is pressed. Now this clutch, so this is a drawing that I have drawn showing you this clutch with the frictional lining materials here. So now when the spring is active, okay, so what happens is it will exert a force or a pressure in the actual direction, okay, which comes into contact with the frictional lining material. So as it comes into contact, or as the force comes into contact with this surface, and when both the surface, that is the pressure plate, and the frictional lining comes into contact, due to this force here, sometimes we call this as normal force, or sometimes we call it as spring force or axial or exile force. So what happens is it will produce a frictional force that is shown in red, okay? The normal force is shown in blue. So these are the frictional forces. So these frictional forces sometimes also is known as the tangential force. So if, let's say for example, if you take the tangential force here, multiplied by the radius, the mean radius of the clutch, it will give us a torque or a turning moment about the center of the disc. Okay, so it rotates by means of frictional force. So with the frictional force, which is the tangential force, multiplied by the mean radius, it actually gives you a turning moment. Okay, so this force here, that is the spring force or the axial force or the normal force, is very important, because the greater this force is, the greater that this force, okay, the greater will be the frictional grip in between the pressure plate and the frictional lining materials here. Okay, so here you have another diagram showing you, okay, the spring force, that is the blue ones, and the frictional force, those are the red ones. Okay, so this red circle here is the mean radius. So the distance from the center to the circle is the mean radius. Okay, and so another diagram here. So you can see these are the tangential force, the moment when the normal force or the normal forces or the spring force act on the frictional surface. So when this force acts on the frictional surface, it also produces these forces here that is in red. Those are the frictional force, and especially when the flywheel or when the clutch rotate as well. So they produce a rubbing force or a frictional force, okay, which is being tangent to the circle that I have drawn. So if we take this tangential force or the frictional force multiplied by the radius, you get the turning moment. So W, that is this, these are the W forces, okay, these four blue arrows here, those are the spring force or the axial force, or sometimes you call it normal force, and frictional force is shown as the red arrows here. So mu is actually the coefficient of friction. It depends on the surface of the frictional lining. So if the surface is rough, then the coefficient of friction is high. If the frictional surface is smoother, then the coefficient of friction is lower. So R, as I've said, that would be the mean radius, because as you refer to this length here from the center to this point is called the outer radius of the frictional lining material. So and then from the center to this point is the inner radius. So this is the frictional lining material. So R1 the outer radius, R2 the inner radius. Outer, that is the maximum radius, inner, that is the minimum radius. And B would be the width of the frictional lining. So the width would be from this point to this point here. So to get to this length, to find this length here, we would have to take R1 here minus by R2. So you get the width of the frictional lining material. T would be the torque that is produced by the tangential force, which is also the frictional force, multiplied by the mean radius. N is the number of pairs of contact surfaces. When you refer to this plate clutch here, I have drawn this side here with one surface with frictional lining material. Actually, for a single disc clutch, you will have both sides, one side here and the other side here. One side of the frictional lining material or the plate clutch is in contact with the pressure plate, and the other side of the frictional lining material or the clutch, the plate clutch, is in contact with the flywheel. So it forms as one pair here and two pairs. The second pair is here. So N is always equals to 2 for a single disc clutch because it refers to the number of pairs of contact surfaces. So P, the uppercase letter P here, shows the power transmitted, which can be found by taking 2 pi nt over 60, where n is the speed in revolutions per minute, and the T would be the torque. So if without frictional force, you have no torque, and then power would be equals to 0. So the lowercase letter p refers to the pressure exerted by the springs. And N, of course, would be the speed of the driving shaft or the clutch in revolutions per minute or revolutions per second. Okay, so now to work out the frictional force, now let us take a look at this diagram. I've already said the red arrows here refers to the friction, and we know that the definition of friction would be coefficient of friction multiplied by the normal reaction, the normal force. The normal force is the force which is always acting perpendicularly to contact surfaces. That means if you have two surfaces which is in contact, then you will have a normal force which is always acting 90 degrees to the contact surface. So in this case, we will take it as the axial force or the spring force or the load. So you have, therefore, frictional force is equals to the product of coefficient of friction with the normal force, that is the spring force in this case for the clutch. So torque, we know the definition of torque is equals to tangential force. In this case, the frictional force is the tangential force multiplied by the mean radius. So it gives you the turning moment or the torque. Okay, so by substituting the frictional force, which is equal to mu W, into this equation, you will form torque equals to mu W, spring force, R, the mean radius, and N is the number of pair of contact surface. So in this case, it's a single disc clutch, so the lowercase letter n here should always be equals to 2 for a single disc clutch. Okay, so that's all for this podcast. So I hope you like it. So if you have any comment or any questions, please put your comments on the comment section in my PowerPoint podcast on this clutch. Thank you very much. See you again soon. Bye.